Alrighty then. Well, thing says we're live. Hey guys, what's going on? Memes here. We're back. Alright. Let's bring this up. Let's try some Ooh. I got programs I haven't even used. Or at least I don't know how to. I should learn. Or at least learn the requisite amount that I can use our powerful new agents to help do cool stuff and things. Alright. There we go. Alright, let's go back here. We need browser window for, oh, I'm in a browser, derp. Alright, so let's do the chat tab. Let's bring up CodeX. Where are we? We're going to try these different things, and we'll see if I can't make heads or tails, or see what works. Alright, we got our Codex engine. Alright. Oh, 5.3. We've got an update. Okay. So, what do we want? Let's, okay. So, you know what? We'll just use the newest one. Let's throw this. Let's go into what we have. Hold on, I need to bring up my other thingies. Real quick, grab this guy. All right, we got chat over here. Wolfram Alpha tab. All right, now we can broadcast our stuff. Okay. There we go. Share. There we go. I know. It helps when we actually. Let's be brave. Share entire screen. Boom. All right. Oh God. Sorry, I hate looking at myself. All right. We got Codex over here. So here's what we want. First of all, I'd like to have a little manipulate function that I know is possible where we can adjust our unit basis. So we can have the meter go down to half a meter and maintain coherence. What was our first prompt? All right. Let's just copy that. Let's just do a new project. New. All right. Please help me write a function in the Wolfram language where I can adjust a dimensional term of measure, such as the meter, and see how adjusting said term will adjust the magnitude of constants of nature while maintaining a coherent framework. Using the manipulate function. All right. No. While maintaining a coherent framework using the manipulate function. There we go. You want it at I feel like that's a more accurate prompt. I'm learning more and more that the correct question makes a huge difference. Okay. So actually, let's copy that. Let's have chat do the same thing. They're both OpenAI products. Let's use this one. Okay. Well, it didn't do more queries, so it seems to assume that it knows what it's doing. Let's see how that plays out. All right, I'll sketch a clean pattern, or rescaling the base unit meter to recompute derived constants coherently, wrap it and manipulate so you can interactively vary and see how the numeric magnitudes change it. Okay, it had something that kind of worked before. The quantity has dimensions. All right, so length, mass, time, current. That's force. I think that's ohms. I think that's joules. Because the length of the unit, like a bigger, smaller, speed of light has a 1-to-1 scale. All right, yeah. Gravitational constant has a, okay, so it scales by, okay, so it's just using S, not as in seconds, but as a scale term. Okay. So I think this is Oh god, this reminds me. This looks like the Buckingham Pi theorem. What the heck is the Buckingham Pi theorem? Aside from a really cool name, Buckingham Pi theorem. Okay, I learned this from Mano from the Wolfram Summer School. Buckingham Pi theorem is a key theorem in dimensional analysis. It is a formalization of Raleigh's method of dimensional analysis. All right. Physical dimension or quantity dimension defined as blah blah blah. Mathematical expression identifying the powers of the base quantities involved tracking these dimensions. I just remember it ended up always at in relationship to the speed of light, because the speed of light, actually you could do c squared in the gravitational constant. Then you just need the Planck mass in the denominator, and then you just need an additional term of length in the numerator. Okay. S to the 1, Planck's constant, s to the minus 2, epsilon naught, it's minus 3, a 1 over length of the third. You can implement this with dimensional exponents pulling from unit dimensions. All right. Reusable scaling function. Okay, so this for length only. So ultimately, we can build at least one workable thing. All right. Let's give ourselves a new notebook. Okay. Let's see. Okay, so let's try this. Copy. Let's run it. All right, so the function's going to be length scale, rescale value, and then we're going to need a quantity. Let's do 1/2. Okay. Oh, we're going to need a dimension, so comma. Let's see. Speed of light. I'm going to need sorry, I should probably have quotations here. There we go. Okay, so module dimension, blah, 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 associate list. Magnitude, numeric magnitude. Okay. So let's try this. Let's just add this code. It seems to list it there. Blah, blah, blah. Let's try this again. Scale, speed of light. Let's take the quotes off, see if that makes a difference. The rescale value. All right, I should probably actually read through everything. Now, some of these are exact by SI definitions, but doesn't affect the unit scaling demonstration. Manipulate. All right. Change the meter scale and watch the magnitude shift. Okay, so modulate. Function name, unit dimension. Okay. Oh, magnitude, optional upgrade, rescale, multiple units. Okay, let's try this here. Oh, okay. Let's get it. It's giving us errors. So let's see what happens. So let's increase the meter by step 4. Oh, whoa. So that was. Oh, this meter at 10 to the minus 6. Okay. Okay, those are the normal dimensions in SI. Is it adjusting? Magnitude times 1000. Factor, okay, that's the factor, but that's not really outputting anything. What's it do for the, it's just showing 10 to the minus 6. It's not actually showing what the actual number is. Okay, but this is technically... Okay. So we're going to do the old-fashioned way. We're going to take a picture, because it hopefully should last longer. Get our whole table in here. Okay. So, all right. Maybe I should actually just go to the manipulate style. Continuous, blah, 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 content height, blah, 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 localize, synchronous. Both sides the same. Okay. Okay, so let's go over here. Grab our little... There we go. Oh God, it doesn't like me. Help. There we go. All right. Please help fix. It is not is not displaying the new values. Please help fix. Okay. There we go. All right, let's see what CodeX got us. What do we got? All right. So we'll do another new notebook. Let's see how CodeX does. All right. It looks clean, but let's see what happens. Okay. I don't see errors in this one. I'm just... I'm just saying it just straight up just divided by those things. Oh. I know those numbers. That's... Okay, let's see. Let's see if this actually works first. Because it's showing the right things. It's just... I know that because I've seen that on like Wolfram Alpha. It's like divide that value divide by 400. Oh, let me make this bigger so we can actually see it. There we go. Okay, so long story short is I just know that because I've seen that number or something that looks a lot like that number. It's got the right dimensions and stuff here. And then divided by whatever that factor is, and then pi and stuff. All right. Okay, it's just... I mean, these aren't... Actually include the fine structure constant, which is good. Because it's just going to remain the same, because it's a dimensionless constant. All right, so let's see what happens. Let's advance forward 1. So we've adjusted by 1. Slide it to like 3. All right, 3. Now, it didn't change anything. Okay, that's it. Okay, let's make it smaller. Our whole table now. Okay, so let's give it a little compliment sandwich. All right. Over there. I like your table. Same, but please express values with Lots. Let me see, how is it? Please express values in SI exponential notation. And the manipulate function does not work, as can be seen in the image. Please fix. All right. Oh, welcome, nerdy. Oh, yes. I know I am. I know. That's the single most important thing I'm probably missing overlooking about topic. That's, again, I just want this stuff to come out. Basically, I just want it to write me. I should probably just learn this step by step. Because I could do it physically. It's just, if I can just let it have me some work, get me some working code where I can adjust, like, let me adjust the meter to a half a meter. How does everything adjust? Let me just double it, because I can do that in Wolfram Alpha. You're just literally just solving for X. All right, this is the one using that. All right, what you're seeing is a grid associated blah blah blah, showing sex length exponent never became a plain integer, so your magnitude fixed code works and manipulate. Okay, okay, so it's saying this should work. All right, so first off, oh god. All right, so clear all. I don't even know if all right. All right, so it's giving me a table again. Okay, so okay, those look like the correct values. Let's adjust. I'll make this bigger. Actually see what's going on. All right. All right. So old, new factor. Here's our factor. Let's skip ahead. Okay. So new dimension, new magnitude. Still not working. Still not working. Oh, wait, no. Maybe I just need to apply that actual code. So it was run. Okay. I should get one. Let's see. Well, it's not working either. All right. We're just going to assume it's my lack of knowing the proper question. I'm just going to... All right. So... All right, so we'll go back here. I know. So choppy. All right, so... Bring that over there. It did not work. Here is my error. Please help. I'm creating urgency. I used an exclamation point. Oh, okay. So it's not even querying anything. So I don't think it's gonna work. Overview. All right. It's CodeX. This is the fixed version. Remember, it's telling us it's fixed. Okay. I mean, it's just within the manipulate function. I should be able to adjust that. So let's try this again. Okay. Boop. All right. Let's say big money, no whammies. Okay. Let's get to, oh. So it's only adjusting something for the fine structure constant. Okay. So if we go into -3. Okay. So again, still broken. Okay. It still doesn't work. Here is my error. I wonder, I almost suspect maybe I should just bring up a Python console. That I think there's a lot more training data on that, so it would probably work better. I might have to do that. Okay. Fixed. Don't use association at all. Okay. Test it immediately. All right. Let's test this immediately in our first notebook. It's almost like how you would normally try code. All right. It didn't output a dang thing. All right. Oh, God. Yeah. Still not working. It showed this. I'll make it think. It's like, all right, dot dot dot. It's like I'm a human meatbag. I'm feeling a little distraught. Okay. Oh, it's a fixed version. Okay, at least it's thinking, quote unquote. Alright. Da, 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 da. Well, music is a very powerful thing, Jax. It's a single. Okay, so those are thinking. Let's just go up to our expression. Let's just ask the. Let's create a new notebook. All right. Let's just use the mathematical assistant. Help. All right. Boom. Oh, I must be lagging a lot. Okay, let's close that other notebook there. That's probably using a good deal of stuff. Let's see. Oh yeah, I should probably close that. Maybe blah blah blah. All right. All right. So on to the bottom. I should get one. Hold on, it should say, was this the one? I think this is it. Test immediately. Okay, didn't work. So I have two separate issues, the old and the new. The small Wolfram language, gotcha. All right. Apply it all as oral, blah, blah, blah. After. Okay. So maybe that's just, all right. Clear all. There we go. Length exponent. All right. Length. Rescale value. Let's just clear them all. Length exponent from unit. There we go. All right. I remember something like that. All right, cut the code. Length exponent. Blah, blah, blah. All right. Value of 1. Roll delayed. Oh no. Oh, say it isn't so. Let's make this bigger so I'm just assuming it has issues like me reading certain things. Okay. All right. Still not working. Nope. Still not working. Here is my error. Please do not say it is fixed code unless you are certain it is fixed. That's all. Just tell me you think it is. I think it might work. That's an honest answer. If you say it's fixed, it is fixed, and it's not, I might become a distressed human. You don't want to distress your humans. I'm so catty. I apologize. All our future agents watching this, I'm sorry. Human flaws. All right, what do we got from CodeX? Nope, that's that one. We're going to use that for the Mathematica. CodeX is here. Okay, the error comes from fine structure. Why do you have the fine structure constant built in? Why is it? It's dimensionless. That's the one thing that's not going to change. Okay, let's go to its notebook, which is this guy, number 2. All right, so let's actually just quit out of that. Let's just throw it in this notebook. Actually, no, that's the one we're actually using the other Notebook Assistant for, so we'll do another one. Just because there's all those things that I've said. Okay. Well, at work, I have my doubts. Let's see. Okay, so it's not doing anything. Fantastic. I feel like I'm asking the wrong question. I think it's going to have to be what we set those other things to. What we got from our... Oh. Gateway timeout. We didn't respond in time. Oh, no. Oh, that's not the most reassuring thing. Okay. It's going. It's sending its thing. Big money. No whammies. Big money, no whammies. Okay. All right. So let's put this in CodeX. All right. Here is my code that currently doesn't do anything to the output, to the manipulate table it produces. It's the code. Please help. Okay, let's see if ChatGPT. You're right to call that. Oh, basically it's not fixed yet. I can see exactly why. Okay. It avoids my warning. Is more formally robust. Just exactly. No comments inside the cases. And test it. Okay. Test what I should happen. Okay. Don't tell me it's right and it's not going to be right. That's all. I don't know. All right. So clear length exponent. All right. So clear all. All right. So length exponent. Boom. Clear that. Boom. Do our little test. Should give us 1. Okay, it gave us 1, but a whole... Okay. How about this? Let's change it to 2. Okay. Yeah, it's really broken. It doesn't work. It like manually said 1. I'm like, okay, yeah, manually you said 1, but with errors, and then you move it to 2. Doesn't work. Yeah. Still totally broken. Can you fix? Fix. Or should I ask Claude? Or would Claude be better suited for this task? Just be honest. Just be it. Oh God, conflict of interest. Would you recommend I use something else for this task? God, I'm such a dick. I'm sorry. All right. So clear all. Again, I'll probably just wait. Length. Dimensions. It's exponent. Exponents from units. Just do all. Oh. Wow. All right, let's see what we got from CodeX. All right. Add an associate, replace. All right, let's see. Okay, so that did not throw an immediate error. All right, so name, but what is it doing? I mean, is it just going to adjust that? Name, meter. What this? Meter, name, speed of light. But what does it want? Oh, expression. Hold on. Okay, maybe I just... Is it just set for that table? How do I use this? I just need to know the terminology. Okay, evaluate, shift, enter. Okay. I I mean, what do I put in this? Please give me an example. That's all I want. It's like, oh, don't you know what I mean? It's like, not yet. No, I'm a meatbag. I have no idea what you mean. Let's check the Notebook Assistant. Wow, wow. Yeah, this is not encouraging. Uh, I guess powerful tools. I wish I knew how to use them. You don't need to put anything. I'll just paste. Yeah. Yeah. But what it... Oh. Well, this wasn't what I asked for. This isn't what I asked for. I asked for a manipulate interface where I could just where I could adjust the value of a unit such as the meter or second and see how that would affect everything else. Apparently, that's a commonly asked question. Because I feel like if it was like, please show me the Lagrangian for this things, and there's like 120 papers on it, it's going to show me a pretty accurate Lagrangian for a thing. Because people have done that. Okay. You're not a man, you're too very sweet. Parse them away, blah, blah, blah. Code, I'm confident that addresses your speech. Okay. You're confident. Okay, we're gonna... I'm screenshotting this. You're confident. Okay. I don't want to get into one of those dang psychological things where I put myself or it into distress. That just seems... Oh. Okay. It's doing the right thing. Clear everything. Clear all that stuff. Okay. Cleared. It's saying it's safe. It is caveating that... Okay, so there's no errors there. That's a good sign. It's caveating this should not warn. Okay, so it gives 0. Okay. Because there's no difference. In a different way, okay. Alright, so unit dimension length. Okay. So there's no change at the 1. Okay, it's listing those units. What happens to 2? Still doesn't do anything. No. No. Okay, well, okay, hold on. No, we need to go through the full directions. Okay, so let's rescale by factor of 10. Should give roughly 10 times the 7 now. Since A is 1. Oh, wait. No. Let's set this to 1. Let's set all these to 1. Make sure we're doing exactly as it's saying. And that did absolutely nothing. Oh, it's saying Claude is not better. This should absolutely be fixable in the Wolfram language. The issue is version-dependent structure. All right. So, this is still not working. I feel like I am wasting my time. I'm just gonna say that. And I'll probably say some nice things or something. Oh, God. Please. Do something. I think I'm just gonna stop doing this. This is, yeah, it's not... For a noob like me, I'm sure you can do all the great things for it. Oh, the final screenshot finally gave you the missing piece. Just one more low payment of $19.95. I'm sorry. It's giving a very human response. No, from that piece of data, now I know all that I need to do to fix the whole issue. I'm sorry. I'm being unfair. Let's see if, let's try the actual, all right. Dimensional terms such as manipulate. All right. This at least looks good. All right. God, which notebook is it? I have too many notebooks. I think it's this one. Insert and evaluate. Okay. So it... first hits. Rescale under magnitude. Okay, so it's giving... It at least cleanly gave me what the other thing is. Exponent all day. I mean, it's still not doing anything. So, suggestion bar, manipulate style. Do I just need to say it's deployed? Do I need to say that to make it work? Well, still not doing anything. Okay, well. It's good since it names each constant, its length. Hold on, do I need to... Scale, rows, key maps, blah, blah, blah. Okay. The table is nice, but manipulate does not work. Well, I guess a noob like me, I just don't know how to ask the right questions. I mean, it's either that or the terrifying thing is if these agents are extremely good at saying what is generally known. Has nobody done this? Is this... Because, I mean, like, Wolfram Alpha, it shows you the conversion factors. It's just... There should be something that should be coded. Am I just gonna have to use an Excel spreadsheet? I feel like I should just have an Excel spreadsheet. Because I know that will work. Do I just say, well, it's been a good run. I'm just gonna go use Excel instead because this is just infuriating. All right. Let's insert and evaluate. Can the Wolfram thingy do it? Nope, nope, nope. Not doing a thing. Not doing a thing. Oh, this didn't do anything. I think I would be better off with an Excel spreadsheet. No. I'm not asking it to fix it. I'm just saying that I think I would be better off with an Excel spreadsheet. Just direct question. All right, let's go back to our other friend over here. There are we? Yeah. Hey, it's okay. 42 is, I think it's a good number. It's also like the Planck momentum square, like 42.57 something. Hey, Christian, what's going on, my dude? Oh, please show me. I have a friend that he's writing, he's creating a OpenClaw interface for either Wolfram Alpha or something within the Wolfram language. That's one of the big things that I'm just looking at. I'm like, listen, as long as we can set it up, just let me ask a natural language what I want. If not, I will just create a ginormous spreadsheet to do this because, well, I mean, Professor Wolfram did this back for like, oh god, I remember at one point it was at the early days of the Wolfram Physics Project. Him and Jonathan Garrod, and I think maybe Max Piskanoff and a few other folks may have been there, and they're just kind of going through, and then they're like, "Well, we're gonna need to have some tables or something for this." And then Steven pulls up some random document he had from like the 70s or 80s with all these different like table identities and stuff, and he's like, "Oh, okay, maybe it's a good thing I kept them around." I just think it's fascinating. But dude, no, absolutely. Either Discord, my email here, or wherever the Twitters or something. I'm on the Wolfram Institute Discord there, so absolutely. Just feel free to hit me up. We can connect. We can chat, share notes, and uh, I'm trying to make things accelerate. And it's like I'll just do it the old-fashioned way. It's like I really don't care. Most of the stuff I learned was just like playing around with Wolfram Alpha to try to do these different things, and it's like I know it has the ability to do. I drove some folks crazy because at one point when we were finishing up the summer school, a couple of folks said, just bring up a notebook on your computer because I was trying to describe a particular technique I learned from somebody else to go through things. And they get all confused. It's like, that's not a normal Mathematica notebook because it was the Wolfram Alpha edition. That's how I learned. And also, some of the things within Mathematica. Example, if you type in universe vacuum energy density, very often it gets confused about things, some of the inquiries, but I can type it straight in to Wolfram Alpha, not even the paid version, just the free version, and I know the magical words to put in to get the appropriate thing that I want. Within the Mathematica notebook, when it sends out the query, maybe it's timing out, or maybe the link to what it's interfacing with within the Wolfram knowledge base is a very slightly different thing. Because some things there, you're looking at it, it's like, this is this, but then it actually has like an actual numerical value via another link there. And what gets displayed in that, listen, it's not a perfect system, but it works really dang well. Cool. Sounds good, Christian. We'll catch up, my friend. You take care. All right, where are we? Oh God, where was I? All right, here's a slightly modified version. Okay. I understand your okay, this is at least an honest answer. At least the Wolfram Notebook Assistant's giving me an honest answer. This didn't do anything. I think I would be better off with an Excel spreadsheet now. I understand your frustration. Blah, blah, blah. Let's try a few more steps. Okay. Okay. Please try again. It gave me an honest answer, not the, oh, let's see. Okay. There's a streamlined version of the code. Okay. Again, okay, after this session, I think I did download Excel. And there is, at least according to Stephanie, there's a Wolfram plugin. That's all I need. Just let me just have a few queries there and just set up this times this is this. That's all I need. Or heck, I'll just set my own dang variables. All right. Let's see what this does. Okay, there we go. Two things. Speed align the gravitational constant. Will it do anything? Nope. Nope. Still nothing. Thank you for trying. I mean, it sounds so sad. Oh, God. I'm sorry to hear that. Okay. Okay. Again, it is probably user error. It's probably user error. Okay, let's go back. Let's see. Chat said it. You finally gave me. I'm not wasting my time. Okay. Scale 1. There. All. Length. LE, rescale value, we're clearing everything. LE, from unit, blah, blah, blah. Oh, wait, I just do clear all that, isn't it? Derp. Those small parts are slowly coming back to me. So copy code. Okay, so now it should return 1. All right. Remember, it should return 1. When we do our length. Okay, so it returns 1. What happens? Okay, no. Let's not break it. A rescale function will then work. All right. Then clear all. Okay. Rescale value. All right, magnitude 10. It worked. Oh my God. It freaking worked. Huzzah. Okay, so I have not been wasting my time. Okay, thank you. Okay, so what do? We increase the meter by 10. So that would set the speed of light. Change it by a factor of 10. Okay. Cool. All right, so if I want the general for any unit dimension. Okay, you know what? You done good. I am impressed. I am impressed. Okay, at least did that. Now will it work for the other thingies? Okay, so 1 second. So it's just showing, I think, that unit dimension there. Okay. Let's run new definitions. Okay, so now the question is, go up by 100. Should go down to 6. Okay, that is working. Okay, I can confirm that that is at least working. All right. You got a thumbs up, my friend. Okay, because your full form, especially blah blah blah, shrink keys, the above code will occur in burning. Okay, exactly. Okay. So we should be able to show a little bit more. All right. Let's see what we got. Suggestion bar. Let's show more. I would like to show dimensions, if possible. I understand what it's showing. All right. What happens if we send this to Wolfram Alpha? Oh, it's just going to give us the number and round. Okay. All right. So let's... Okay, so what is this next part? To make this easy, to scale time, mass, etc. later. Okay, so quantity. All right, so the string, so the numerical. Okay. So that's the thing. Okay, so it's operating on the strings of digits. Okay, maybe that's kind of hacky, but you know what? So it's setting the variables. Okay, hey, man. That's how it's working. I mean, heck, I've heard Stephen Wolfram at least a number of times saying, well, somebody that's been in for Wolfram research for like 20 years, it's like, blah, blah, blah. And Stephen's like, yes, I remember when we did that. That was just a complete hack. All right. So thank you, Notebook Assistant. All right. All right. Cool. So, all right. Let me give it the update, the good news. Okay, let's go back to 10. Because I did confirm it did work the other way. All right, so... All right. Let's make it a little bit small. Let's get the whole thing in there. Let's reinforce it. Reinforcement learning, they say. All right. All right, got our cells and stuff. Excellent. Great job. Actually worked. I feel like this, I need to restate the questions a couple of times. Okay, so grab this. It actually worked. Put that in there. And we adjust so that we may see. Oh, I'm asking it the wrong question. See, I'm realizing right now that this is actually you. Okay, I apologize to all our agents out there. What ultimately I want to do is I just want to set all these dang things to 1 like we normally do, and then see how things would adjust if we adjust like the meter and all these other things. Is that what? Oh God, I don't even know my own question. There's my flaw. So we may see the unit dimensions associated with the output digits. All right, let's see what CodeX said. Where's CodeX? This guy over here. All right. So which notebook do we have? God. It's 1. Okay. Fortunately, 3. Let's just create a new notebook. File. New. Notebook number 6. is it because it's trying to do so many different sliders? Well, to be fair, it didn't give me. And then evaluate shift enter. All right, so shift enter. Okay, I'm worried because it's using logs now, but I claim logs are useful. All right. Okay, so it's at least. Okay. All right. So major errors, major errors, major errors. Okay. Um. Yeah. Yeah. I I really think. Uh. I think this would probably just be far more just useful just doing it manually. Okay, so don't save. All right. So ultimately, the best answer we got to something was ChatGPT 5.2. Okay. So we spent over an hour fighting with something. We magically seemed to get something to work. It's okay. All right. Where are we? Okay. Let's see. You can absolutely show the dimensional figures and or expressions. All right. Both on the table. Okay. Now it's getting fancy. And now I think it's getting to the point where. Okay. Class dimensional string. Blah blah blah. All right. So we got this block of code. Set that, and now we get our string. Should return 1, and then whatever modification value with units. Okay, so that's. Okay. Oh, this is the block. Boom, and then. You're self-inserting the number in there. I mean, yes, but I could tell you it would be that. Let's do it. That's okay. So 100, yeah. My question is, does it go the other way? Let's do 1/2. Gonna get confused. Oh, it seems to do a pretty good job. Okay, beautiful. All right. Okay. So what I'm learning from this, I just need to just set all the variables and just. Okay. New unit rather than same unit. Okay. Maybe that's what I'm not communicating correctly. Let's see. This table, that's a very grand claim. See what happens. Okay, so when I went up by, all right, 3, 4, 5. Okay. Okay, so it seems to be working. Okay, so when we go to 10 to the 6 meters, it goes down to that. Oh, it was okay. That's why I was listening to gravitational constant as 3, because it has 3 derivatives of meters. So it's got 3 for meters in the x. That's why it was saying that. Okay, okay. Duh. Okay, so that's gonna change it to that. Okay, so it's gonna go up by 3. Okay, 10 to the 6. So then the old digits. Okay, so if the meter was basically, was that a micrometer, something like that? 10 to the minus 6? 10 micrometers? Uh, micro. Yeah, something like that. Mm, oh, so 10 to the minus 6 gravitational constant would go. 42,000. Oh, so it would decrease. Okay, so what do I want to go down by? Well, 4 magnitude. Okay. All right. You're gonna get a thumbs up, my friend. 'Cause that actually seemed to work. All right. God. All right. So we finally got that. All right. Okay, so what was the ultimate thing for this? Alright, clear all units, clear all units dimensions. Okay, so it's at least a working rescale. Alright, so file, save as, working length, manipulate. There we go. Okay, so that at least works. We got something done that was better than we did the other day. We exponentially output more useful work than the last time I tried to. So good God. All right, save the cloud, working length, manipulate. All right, so after an hour of fighting with 3 different language models and stuff, hopefully, hopefully friends will be able to save me from the institute, or at the institute will be able to save me. Okay, it's getting a little bit late. All right. My caffeine is wearing out. Feel like Ultraman. Ultraman can only maintain his gigantic form for 3 minutes. Time is running out. All right. Where are we? Ta-da. Okay. Then let's publish. Just in case if anybody wants it. Or build upon it. So God, I know people can do a heck of a lot better stuff than what I just did. I didn't even do it. Oh, just got into a frustration match with some poor agents. I feel like I made the Wolfram Notebook Assistant feel bad. Yeah. Heck, I have no idea if I'm conscious. I have no idea if these things are conscious. Again, I usually just feel like a lame language model personally, so... let's go. There we go. Alright, so just in case if anybody wants this monstrosity, it is available right there. Okay. So... I think that's about all. I gotta go take care of maybe a few other things, so. Alright. Whew. That was. I should have just had to do just a data analysis. It makes me wonder. I'm like, in that short session, it improved. Are these things kind of like Saiyans, where it's like the training data is just kind of like more battling, it gets better? Because I'm like, has nobody asked it to do this? And then I just refined it, and once it got it, it seemed to be able to do the table, which seems like a much higher level of complexity to me. Are we the training data? Or the questions and everything being iterated? Because ultimately, if it can output something that works, because that's the thing, whether you know how to code or not, it's just the code works or it doesn't. Now, it might be buggy, and maybe there's an astronomical exception, because occasionally that happened. There was some weird random string of digits somebody found that's like, yeah, nobody's ever output this exact string of digits, but it technically would break this calculator or something. So, all right, where are we? So, Yeah, that's about all I got for right now. I think that's all I really have the tolerance for at the moment. So I'm gonna try to start getting these things, doing these a little bit earlier in the day, just because I've been on Mountain Time for a while, and I just need to just wake up more early. To be fair, I'm gonna need to go to sleep more early, just because I do also probably need to get back to doing the old day warehouse job, as kind of need money, so gonna have to do that. But hey, man, Jax, no, I appreciate it, man. It's like, again, I'm not gonna pretend like I really know what's going on. It's just like just refining questions. I'm learning more and more that things are accelerating at a rate that I didn't even expect. I'm like, all right, I knew some of these things were technically possible in my mind. I'm like, okay, well, if we can do this and this, we should be able to do this, this, and this at one point. Now, uh, hey, Pixie Lord, uh, no, hey, man. I'm sorry. I'm assuming things. I am assuming things. I apologize. Um, again, I don't know what I'm doing. I'm trying to get a frame just for my knowledge, just so if I can adjust things, see how things look. Just because the interesting thing is some of the conjectures that I have. Again, I'm not gonna say that that's the way life is or the universe or anything, but it's like I keep coming back to some level of quote unquote unity with like our current system, which is a weird thing because the unit basis shouldn't matter. Only dimensionless things like the fine structure constant should, but I'm seeing interesting relationships between certain things, and I'm like, how the heck could there be a preferred basis of units? And that's a weird thing. But occasionally it's like I'll get out like 1 joule second or very close there, and I'm pretty sure that just has to do with like the quote unquote induced curvature, whatever that may or may not mean, of the Higgs scale. If you do the quote unquote spherical God cow, so you just take the mass energy of the Higgs boson, literally turn to a spherical cow by dividing by 4/3 pi r cubed, where r cubed is its associated Compton wavelength. You multiply by the Einstein C4 constant. That's that constant of curvature, the kappa constant, which is basically 8 pi divided by the Planck force. Or Planck force, yes, that one. Or was it 8 pi Newtonian gravitational constant divided by the speed of light raised to the fourth power. Yada yada. Long story short is you get about 1 reciprocal square meter. You take the square root, it's the induced quote unquote length of curvature or distance of curvature by the Higgs boson is quote unquote about 1 meterish. That's why I assume I get some of those numbers just because. Oh God, here, hold on. Where's that stupid? That's stupid. But just a random crazy calculation. Where is it? Oh God, it's in one of these guys over here. Ba 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 ba. Okay. Feel like I've totally lost my mind. Hold on. Let's just do it in the tab that we got. All right, so share this guy. Yeah, it's just because the kind of crazy thing is, let's show this guy. Boom. All right. So the crazy thing is, what's it? Eggs mass, speed. C squared should work for this. Divide by 4/3 pi Higgs Compton wavelength cubed. Boom, boom, boom. Gives this number here. Of course, I need to write the speed of light because it's going to think it's the charm quark because I'm talking about speed of light. There we go. Gives you this ginormous number. Okay, the weird thing is when you multiply by the Einstein constant, the C4 constant. Well, actually, the C2 constant's interesting because that looks kind of close to the speed of light squared. let's take the square root. Okay. So the speed of light technically has a frequency of like 299. It's like basically 299 mega, or it would be 299, so it's a little bit above it there. But when you do the C4 convention, speed of light to the fourth, I'm like, oh, it appears to be just of magnitude 1 reciprocal meter. I just thought that was kind of interesting. That's also probably the whole reason why, if you just take like the Higgs mass divided by the Planck mass. Okay. And again, this is the hierarchy problem. I'm not saying that this is the solution to the hierarchy problem. It's an interesting conjecture that was interesting enough at the time that I threw in a t-shirt. Now, it needs to be in these dimensions for it to work. That's the weird thing. Because if you try to do it electron volt seconds and everything, you can't just do that unit. It would almost infer like the joule second is meaningful. So hold on. When we square this, we get a number. 1.05 times 10 to the minus 34. Okay. Coincidentally, that just happened just numerically, and this is a numerical coincidence. The magnitude of h bar, the first 3 digits, is 1.05 times 10 to the minus 34 joules seconds. Okay, so full disclosure, this is a dimensionless number. At that point, what would the claim be? That our current SI, or the SI unit, and or the meterish thing, because, what do we set it? We define the meter, or excuse me, we define the second first as the oscillation frequency, or the number of oscillations for a cesium-133 clock, blah, 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 and then that's how we get out the meter and everything. So interestingly enough, we're kind of using time and stuff for that. But the interesting thing is, if you take that ratio and you divide h bar into it, or you divide it into h bar, you get out 1 joule second. So essentially, that's the same reason why, if you do this quote-unquote trick here, because this is... I'm going to do a hack. I'm going to use the reduced Higgs-Compton wavelength, because that's how you have to do it for this to work. Because we're going to compare it to the Planck length. The Planck length is a minimum. It's technically the reduced Planck mass Compton wavelength, because the Planck length is a minimum of length, so if you need a wavelength, you need to multiply by 2 pi, which I believe is also the length of a string with an M theory or something like that. So divide this by 2 pi. Okay. Square that. So here, I'm going to rip this out. Hold on, let's not take the square root. We're going to compare apples to apples, or oranges to oranges. So what's the claim? The claim is we're taking the mass energy of the Higgs boson. Where actually we need to get rid of this 4/3 pi. We're going to use the reduced squarical cow god, or cubical. It's that little cube cow. We're just cubing the normal thing. We're not even turning it into a sphere, because now we can compare apples to apples to the Planck pressure under pressure, which is basically okay. So the cosmological constant problem, quote unquote. Okay. It's that 122 orders of magnitude. That wasn't really a prediction, but maybe it seemed natural. But the Planck pressure within our unit of Pascal is like 10 to the 113. See, 4.6 times 10 to the 113 pascals, our unit of pressure. Okay, that's the definition right there. All that speed of light, gravitational constant, h bar. Okay. Now, when you divide that into the universe's vacuum energy density, you get like 122, 123. 10 to like 123. Okay. Why? It's like the 120 something orders of magnitude difference. Now, it's like our same term. Let's divide it into Our spherical God cow. God, why did that pi? Oh, that was right plate pressure. Okay, what's the magnitude difference? The magnitude difference is 1.1 times 10 to the minus 68. I looked at this, I'm like, it looks kind of close to the Planck length squared. I'm like, all right, let's do this the other way for notation's sake. So here's what we're going to do. Just because it will look more neat, I'm going to divide it this way. I'm going to divide the Planck pressure by our spherical cow god. Okay. Because the Planck length squared is length squared. It's like, yeah, like 10 to the minus 70. And if we do 1 over it, yeah, it's 3.8 times 10 to the 69 inverse meters. Okay, so we're just going to take the Planck length squared. So we got a really big number. Bracket it. So we don't have any funny commutivity going on here. Oh, God. What did I do? Let me copy that one. Yeah, edit, undo that one. All right. Oh, maybe I just did it right. Okay, so Planck length squared. Okay. I'm just looking for a oneness here of something. All right. All right, so it's a little less than a square meter. We could take the square of that. Okay. So let's take the square root of that whole dang thing. How close are we to 1? Okay, so that's about 1 over 2 pi meters. Probably why that spherical cow god thingy seems to even work, because if you just look at the numbers there, it's possible closed forms. Okay, 1 over 2 pi, but there's a difference there. It's giving us a 4. That would be a 9. Okay. So that would be if we use the Planck length. Is there something else that may fit a little bit better for us to fill in the quote-unquote gap? So, number 1, we should note... Oh, let me just delete this, because we're going to do the same thing. So, and again, I'm getting around to the point. Is there a particular thing we could put in here? And again, this is a dimensionless number. That's the weird thing, and that's why I want to look into this more, just because it seems like a crazy thing, because it would infer there's a particular preferred scale. I don't really think that should be a thing, but there are a lot of weird coincidences that you could actually maybe provide some explanations for if we assume that was true. Again, I ain't no god nor prophet. I wasn't there at the beginning. I don't know what's going on. I'm just a pattern matching creature. So let's say rather than doing that, let's do h bar squared, the elementary unit of action squared. Okay. Now, I don't necessarily know what all those things are, but that's saying 1. It's like the square root of this whole dang thing. What might that be? I mean, I've already given away the plot here. Looks to be pretty close to 1 joule second, which also happens to be equivalent to about 10 to the 7 erg seconds. I feel like it's a very underappreciated, depreciated unit. Personal opinion there. Why this is coming out this way, it actually shouldn't be a surprise. At first, it slightly surprised me, but then I realized that whole Higgs mass over the Planck mass, there's actually a second Higgs mass in here. And to be fair, what we're comparing is... It basically comes down to Planck's constant of proportionality, because that's essentially what it is. Because the Higgs reduced Compton wavelength is a magnitude when you plug it into Planck's constant. It's going to give you, it's equivalent to the Planck mass. It is literally derived by definition, and my friend Hans corrected me on the definitional loop that I was in there, is the Higgs Compton wavelength is literally, or its reduced Compton wavelength will give you literally h bar. Or at least that's the same ratio between the Planck mass squared and the Higgs mass. Now, that same constant proportionality is basically between the Planck length and the Planck mass. So basically, we're just using that other expression of the Higgs mass divided by the Planck mass squared. We're just taking it up to the fourth power. So that's why this ends up being a thing. And the best reason I can guess for this is when we do the quote unquote spherical God cow, is it comes out to be pretty close to about 1 meter. So since that's on the 1 meter-ish scale, that's probably why that works, and also would probably explain why this is the hackiest thing that I had found is so in let's just use this. Universe vacuum energy density. It's about 5 to times 10 to the minus 10 joules per cubic meter. Okay, it's an energy density. It's pressure. Because I mean, that's what it is. That's an alternative interpretation that it's not showing up right there, but okay. So the interesting thing is Planck energy within the same units, 10 to the 9 joules. When you do 1 over the Planck energy, you get 5 times 10 to the minus 10. Now, it's in completely different units. So that's obviously not right. But 5 times 10 to the minus 10. What if we do the most naive thing? Joules squared. Just literally fixing the dimensions, just shoving in meters, a human construct in there. The joule is a human construct based upon our unit definition. The meter is definitely a human construct. Huh. It seems pretty dang close to the, to be fair, it does need a pi divided by 3 convection term there, but if you think it is the cosmological constant, which is the vacuum energy density is, and it's inducing curvature, oh look, pi divided by 3 joules squared divided by meters Planck energy. And it gets weirder because if you want the cosmological constant itself, you literally just add in the extra little terms there. You add in, this ends up, it has 8 pi in it, so that pi gets squared. We add in an 8, it's still divided by 3. Still have joules squared, and then we just add in Planck force. So we get about 1.1 times 10 to the minus 52 reciprocal square meters. It's divided into the cosmological constant. Oh, excuse me. Divide. And again, the cosmological constant might not be constant, but just with this formulation, at least with a little bit of rounding, it appears to match it pretty dang well. This is the tangent of roads I'm going on. Just because I don't know any better, I'm like, what would I need to throw in there to make it be right? I'm like, okay, well, there's also a geometric way you can kind of go about this too, because basically I was setting 1 joule equal to, and then if you take the square root of like the Planck mass or energy, and that if you include that pi over 3 term, it ends up being the geometric mean to get about 1 joule. Because I saw this before, and I'm like, oh, this is crazy. I can't justify this at all. I started going through, but then even still, I was setting it equal to 1 joule, which is basically, it also has a relativistic mass, which is the conversion factor between the speed of light and everything. But again, if I was to take this coincidence seriously, this would imply there is a quote-unquote preferred scale. Now again, maybe this is an artifact that the metric system was kind of initially based on the density of water, because about 1 cubic centimeter of water at standard atmospheric pressure at around 4 degrees has about a density of 1 gram per cubic centimeter. Hence, a cubic meter of water is really dang close to 1,000 kilograms. It deviates in like the third significant third decimal place or something. Um, what does that mean? Is it water all the way down? I don't know. We got a surface covered with mostly water. The sun is approximately the density of water, like 1.4 ish, something like that. So it's like, I don't know. It's a weird thing. I can't justify it. The best justification why I have that this works is just because the quote unquote spherical God count seems to come out to be about a 1 meter-ish scale, or even with or without that slight adjustment. It seems to be an interesting thing. Is that built in? Is that just a numerical coincidence? I'm just going to chalk it up to a preferred coincidence. It's just the induced curvature at a meter-ish scale it sounds a lot more justifiable than saying, well, we just got lucky. But then again, it's how lucky is it that we're here? If we just assume statistical probabilities for us being at just the right place in a galaxy that's not actively has an active galactic nuclei emitting all these X-rays, deadly X-rays here. We happen to be in the Goldilocks zone for a single star planet or a single star system that doesn't have to deal with the three-body problem or all these other crazy things. And we happen to have a very large moon that we may or may not share the magnetic field and all this other jazz with. It's like, I think just statistically, the chance that any of us are here to be able to even talk about this stuff, I think by definition is a miracle. So, who knows? I think maybe existence might even be stranger than that. So, but that's all I got. Dr. Smith, long time no see. Good to see you, my friends. Good to see you. Oh, as well as we got Charlie here. Welcome, Charlie. Where are you in like meters? Blah 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 blah. Press original argument. Gravity information, Planck scale, Planck spring constant. So maybe I should do something on that the other day. I know I said I was going to stop like 20 minutes ago, but sorry, you guys prompted me in a particular way. But the difference between a neutron star and a Planck mass black hole is about 78 orders of magnitude, which apparently is the Planck spring constant in there. Okay, one last thing. One last thing. Sorry. It prompted me just right. All right. So let's go. Neutron star density. And again, there's a range. We don't specifically know. We haven't been there. All right. So it looks... All right. Kilograms per cubic meter. All right. So let's just take the high end. Just take again, it's got a little range there, so we're just gonna literally take this. Okay, kilograms per cubic meter. All right. So let's divide this into the Planck density. That's again, that's an interval. What was that? Maybe a 3. Oh, hold on. 2, maybe 3. Okay. So it appears to be a little bit above, because the Planck density is basically the density of like a Planck mass black hole. So we look at that number. The Planck spring constant, at least dimensionful, is like mass. Not that one. Like mass. I'm a masshole. It's okay. Divide by the Planck time squared. And now again, this has units kilograms. Divide by second squared. 7.4 times 10 to the 78. That's 8.7 times 10 to the 78. Again, this is a dimensionless ratio. I just find it interesting that it happens to have a difference of about 78 orders of magnitude, and again, it's not exact. It has 0 significant digits. It just matches the magnitude. But this is a 7. I'm just saying that, well, if a neutron star is the maximum nuclear density and stuff, and a black hole is technically at its minimal scale as the maximal density, because don't remember, it's got that factor too. So as a black hole grows, once it gets to be the size of the solar system, it's got like the density of cotton candy. So actually less than the density of Earth, which seems like a very weird thing. Um, it stems from it's like, okay, so can a neutron star ever directly collapse? I don't know. It looks that like some stars, and I think there was a recent one where it just seemed to collapse. No supernova. It left a little bit of a remnant, but didn't go cosmic full on kablooey to at least what it normally is, and it appeared to directly collapse into a black hole, which then raises the question: how common is that? How many monsters might literally be hiding there that just we didn't even know? What if most stars do that? Or there's a particular range? It would seem that there would be more quote unquote invisible mass around. Just something to think about. Golly! What's going on? Um, all right, let's turn individuality. Okay, maybe. Um, Kali was one of the folks that helped get me on this because I still I like the generalized neutron decay concept. That's the easiest thing I can get to. Just even with whatever quantum cyclic cosmology, or if you use whether trefoil, Shirley's surface, the figure eight knots complement, or something. At least according to Thad's calculations, it gets down to about the classical charge radius of a neutron. So I'm like, all right, if we let there be light, and you just get it condensed, and again, one of the other things I learned from Kali was, yeah, light really doesn't take 90-degree turns. Like that's kind of like the maximum there. But I'm like, if you have the figure eight and it's going around a Mobius twist, it's being deformed smoothly in a way. I'm like, well, if we had a Planck energy worth of photons and just light going through that, might that be wrapping it up? And at that point, you're gonna output neutrons, which eventually can decay into all the wonderful stuff and things that we love. And you get all your building blocks from light itself. And again, I'm happy with Big Bang nucleosynthesis or whatever, the cooling, quark gluons, plasmas, and stuff like that. Maybe I'm just like, what if we just boiled it down to a field configuration and what's the simplest thing? And I kept on going down. I was like, okay, neutrons. Well, neutrons decay. What about neutrinos? I don't know what a neutrino is. I'm like, well, when matter and antimatter annihilate, what do we get? Photons. It's one of the things that I learned from John G. Williamson. It's like he had the trefoil version of the electron and stuff. It seems to match pretty well. There's some slight deviations there. Oh, God, I really need to go through his derivation. I owe it to him because he at least spent the time to answer some of my questions. And he seemed like a good dude that was, in the most polite way possible, to tell me why I was totally wrong. But, okay. I'm done now. All right. So, hey, thank you all for watching. I'm going to try to start doing some more interviews with some interesting folks around, and maybe bring some folks together that may or may not have some things in common, and see if we can't moderate and not having people get as offended as perhaps we need. So that's all we got. So peace out, everybody. Take care of yourselves. Let's hoping for a better tomorrow. Peace.